Okay, so moving on to question 2 here, you're told that you have a lamp, and in that lamp you're asked, examine figures 1 and 2, which lamp is more efficient, and justify your answer. So if I'm looking at a lamp, I want to have more light or the most light energy produced. So that's figure 2 because it produces more of the light energy, and that is your justify your answer. Over then onto part B, why is it important to improve the energy efficiency of household devices? So it prevents a waste of energy or energy dissipation, particularly electrical, but any energy. Next, you're asked here, a student is asked to investigate and compare, and you're asked here the heat energy, and that's really a big clue in the first part. So name a piece of equipment that could be used during this investigation. So anytime you're looking at heat, how do you measure heat? You use a thermometer. Then you're asked to explain how this piece of equipment could be used during the investigation. So you place the thermometer on or at a fixed distance from the bulb, and you record the temperature rise. Okay, and you repeat for both bulbs. Okay, so you repeat for both the filament lamp and the CFLs. Okay, and then that's how you measure your rise in temperature. Then you're asked here, so the energy conversions that happen in a CFL are described in the table below. Complete the table for another device which transforms energy from one form to another. And I suppose this probably is a key point here, which you designed as part of your studies in science. So it's not like you can go and say a dishwasher, because you wouldn't have made that device in our studies. We have done a few of these. Obviously, we made a balloon-powered car, okay? So I'm going to put that as our name of our device. The function of the device is for the car to move, okay? The main useful energy conversion, okay? We're looking here at making the car move, so straight away that's kinetic. And it's a conversion, so it has to start at something. And remember, we blew up our balloon, which gives it potential energy, okay? And then our main loss of energy, and when we did this down in the central area, the biggest loss obviously is the sound, okay? So when the balloon deflates, a lot of energy is lost as sound. Then you're asked to sketch a Sankey diagram for the device you described in part D. So if we look here, we're going to start and always state what the amount of energy is that you started with. So that was 100 joules, okay? And it was 100 joules of potential energy. Okay, because that's what we have in our balloon. Now, when we did this experiment, very little of our cars moved in, big distance. So we only had a small amount of kinetic energy produced. Okay, so that's why my line for kinetic energy is going to be quite small. And we might just even say 10 joules. And what we noticed was that most of my energy dissipated as sound. So that's why it gets a thicker line. And that here then will be sound. And remember, the energy that I have at the start has to equal the energy at the end. So if I have 100 joules and 10 are gone, then the other must be 90. Now, those figures, you could change those around, but so long as you have potential, kinetic and sound, and the total energy that's being converted equal to the total energy at the start, you'd get your full marks.